You build an app, and it goes viral. Millions of users arrive at once, but the infrastructure is overwhelmed. The lights on the server rack flash, the system fails, and your entire platform goes dark. To prevent this, companies often purchase massive amounts of backup capacity. But when traffic returns to normal, that expensive hardware sits idle. You end up exhausting your capital to power machines that aren't doing any work. In his book, Bridge the Gap, Sriram Gopalan explains that the survival of a modern software company depends on aligning these scaling costs with actual user demand. Every technical scaling decision is a financial one that directly impacts a company's profit margins. Bare metal is like buying a house. You maintain the hardware, and to scale, you must physically install new machines. Virtual machines are like renting an apartment from AWS, offering flexibility, but you're billed 24/7. Even at 3 a.m., you pay for unused capacity. Owning a physical box requires over-provisioning for peak traffic, while renting a virtual one still results in bills for idle time. Both models fail to solve the problem of paying for unused compute power. Serverless architecture addresses this by acting like a hotel room. Your code checks in, uses a few milliseconds of computing power to complete a task, and instantly checks out. When a user uploads a photo, the cloud spins up a temporary environment, resizes it in 200 milliseconds, and immediately shuts down. With millisecond billing, 0 users at 3 a.m. means a bill of exactly $0. The BBC uses this model to handle the massive traffic spikes that come with breaking news. They can support millions of simultaneous readers during a major event and stop paying for the capacity the moment the news cycle ends. Serverless architecture replaces fixed infrastructure liabilities with elastic, usage-based assets. Code that runs perfectly on a laptop often crashes on the production server due to subtle environment differences. Docker solves this by packing the code and its exact settings into a single, isolated container, guaranteeing it runs identically on any server. Containers provide environmental consistency, ensuring that software behaves predictably regardless of where it is deployed. While containers solve deployment issues, managing them is a logistical challenge. If an application consists of 500 independent containers, how does a human team monitor, scale, and restart them all? Kubernetes acts as an autonomous orchestration system for these containers. It functions like a crane operator, managing the placement and health of the entire fleet. It is governed by a philosophy called desired state. Instead of providing step-by-step instructions, you tell the system what the end result should look like, such as always keeping 3 copies of the login service active. If a container fails, Kubernetes detects the discrepancy and automatically spins up a replacement. This happens in real time, often before a user ever experiences an error. Kubernetes automates the recovery and scaling of infrastructure, removing the need for manual intervention during a system failure. Infrastructure is no longer limited by hardware availability. Modern leaders must choose their architecture based on their specific business goals. Serverless architecture offers a zero idle cost model, but it often locks your software into a single provider's ecosystem. Containers allow you to move your code between different cloud providers, but they require complex orchestration systems to manage. Adopting complex systems like Kubernetes adds significant operational overhead. It should only be implemented when the scale of the application justifies the investment. System design is a series of strategic trade-offs that determine how safely and profitably a company can expand. To better understand these trade-offs, you can find Sriram Gopalan's Bridge the Gap at the link below. Subscribe to our channel to continue exploring the technical foundations of the modern economy.